Everybody, welcome to our webinar today. We're going to be talking about one of Guardian's services called Forensic Data Bearing Devices for search and removal for network server storage. And I'm going to hand over the microphone to our presenter, Andrew and Brendan. Thanks, guys.
Good morning, all. So as Sarah mentioned, we are going to go through the service of Forensic Data Bearing Devices, search and removal for network server and storage. We want to go through what this service is and why it's so important. We are getting more and more customers that are looking for this. First of all, you should know that this is a service that we've always offered, but in today's age of ever increasing data, it's attuned to Moore's law, where back in the 2000s, the increase of processor speeds was doubling every 6 months. And so what we're finding is that the type of data that is being used and where it's being put is exponential these days.
Guardian Data Destruction is a third-party provider to channel partners, to ITADs, to VARs, to service providers, third-party service providers, and resellers. We have a national reach. There is not a state that we can't service, not a back road that we haven't driven one of our trucks down. We have the largest on-site sanitization program in the country. We offer a full suite of complementing services that allow us to provide you with a one-stop solution for your on-site engagement needs, from the everyday shred to the everyday decom to complex and tailored solutions that require all sorts of different service verticals, all in service to getting you and your clients over the finish line. As of late, we've celebrated 15 years with more than 22 million devices protected. My name is Andrew. I am a specialized project manager in the data center services division. My primary focus has been on erasure for my career. In that career, I have sanitized north of 300,000 hard drives. A lot of these topics we'll cover in today's webinar are part of my skill set, and the training program that we've devised here. It has to do with having a granular understanding of where risk lives.
And I'm Brendan O'Byrne. I'm the Vice President of Data Center Services. I've spent 35 years of career in the ITAD industry, well, what's now called the ITAD industry. It wasn't anything when I started, and it's matured significantly over that period of time. I spent about half my years in sales on the asset recovery side and remarketing assets, both as a salesperson and as a regional sales manager. I spent the second half of my career in the operations world. So I've been able to harness experience and skills from all angles. The division, I've been with Guardian now for going on 9 years, and when we took this from projects that were just special projects when I got here to Guardian, to the full division that it is right now. We've developed tech teams that are in data centers and in office environments on a daily basis all across the country. That combination are data center services, our on-site data destruction, and our IT packing and logistics services.
So we're going to cover a handful of things today, from the real world examples to some theoretical, some philosophical notions. And then we'll talk a little bit about, we'll hit the glossary, if you will. We'll talk about understanding some specifics and best practices, and then we'll provide you some resources for some further education. The first thing we'll do is we'll hit two case studies. These are real life examples, not hypotheticals, not potential things that exist only on paper in knowledge bases. These are real things that have happened that we've encountered. The first one is So background, this particular project was a mostly an audit and a pack and ship solution. The reason this falls into the case study is that we were vehemently promised all of the data bearing devices had been extracted from the chassis, from the assets we would be auditing. Um, Not once, not twice, but throughout the discovery and quoting phase, it was there are no devices that you need to pull. So don't uh, don't worry. Uh, Unfortunately, even with that level of confidence, the reality is there were devices left in assets that we discovered on site. Um, Not one or two, 18 terabytes worth of devices from from the small to the plain obvious ones. Um,
Andrew, there were hundreds of devices that we found that 18 terabyte across, correct?
that is correct. Hundreds of devices, and not concentrated in one pallet or one device or one device type. It was ubiquitous across the entirety of the scope. So to give you some notions about what 18 terabytes worth of risk looks like, it is 311 billion combinations of username and passwords. Or even maybe more frightening or equally frightening is 1.24 trillion with a T, a capital T. Like there's trouble here in River City, capital T. 1.24 trillion combinations of credit card numbers or social security numbers. That's every social security number ever issued or ever dreamt up to be issued in the year 3200.
What I want people to understand in the ITAD world, in the industry, it's very, very leaned on quite a bit on the remarketing and the revenue generation. We all lean on that. We have to run a business. You cannot sell enough assets to take care of one data breach. Not only financially within the organization, it takes companies down, and some of these billion-dollar organizations, it significantly dents their reputation. So it's not, besides everything that Andrew mentioned here, that remarketing thing is very, very high on people's priority list in this environment, and I think they really need to pay attention to the risk when it comes to data.
So having said that, to give you some more granular insight into where we were able to find and comprise 18 terabytes worth of risk, they were all over in various types of asset categories, from servers to storage arrays to networking devices. It was ubiquitous. Some of the big players in combining to 18 terabytes worth of risk were firewalls. Firewalls have drives. They have, and the role that the firewall plays in your network requires that it have a large pool of readable, writable data. That number, in this case, we found a handful of 512 gigabyte solid state drives. That number isn't going to get smaller as networking continues to proliferate, and as interconnectedness is the sort of the buttress of our ability to do business. The 512 will go the way of the dodo, and that number will increase. In servers, there were 8 terabytes of SD cards for iDRAC and ILO control for VMware. For boot image, iDRAC is a Dell acronym for integrated Dell's remote access controller. It allows you to configure the machine in such a way with ports and networking all built on SD cards that are in the machine to have remote access and control over that device, such that if you need to work on that device, you don't need to go be physically where that device is. That could be having sort of the shape of the key and the key to the kingdom for how one particular organization were to utilize remote access to their devices is really a frightening reality if that were to get into the hands of a nefarious actor. It says, hey, we use this type of key and this type of lock only. That's a frightening picture to let someone peek into if
So
they intend
and those
to do
are
harm.
in most of your servers and storage devices that are out there, because we know we're in colo locations and people are remote, so they need access to their devices because they're not on-prem. So these are very prevalent, but very understated when people don't talk about them. Anyway.
Correct. And that was an explanation of Dell's iDRAC. All of your OEMs have the ability to roll out remote management. So just calling out Dell would be unfair. HP has it, Lenovo has it, Sun had it way back at when. So it's not new, but
Okay.
the risk is real. And then there were as the biggest player was the blade chassis with 128 blades that we needed to open for visual inspection, in which we found just north of 10 terabytes worth of unexpected, unaccounted for data-bearing devices. So having said all of this, I'd like to go back to the top of the story where we were assured that all the data-bearing devices had been pulled, that there was no need for us to look. We looked, and we found a tidal wave of risk that we were able to mitigate on site. So that's case study 1. Case study 2 is at the total other end of the spectrum as far as how it presents itself and what the response is like, but the risk is still as significant. I'd like you to look at these two pictures and just to yourself for a moment, contemplate the difference. The difference is that the one on the left is a port replicator. It's the little box that sits on a hot desk for people that come in and work a couple days a week and share a desk with other coworkers to plug their laptop in so that they can have extra ports, but they only need to plug one thing in. This box goes right into their laptop. The one on the right is a smart docking station. This particular device, although it has the same footprint, same look, same ports, is significantly different. And the difference here is that it's powered by Microsoft Azure. It allows for remote management and remote control over the device that it's attached to, the end user's laptop. If they put it down, plug it into this, the Microsoft Azure component of that the end user's IT department can push out firmware updates, push out security updates, restart the machine, wipe the machine. There are all sorts of things that allow the IT department to remotely manage end user devices. Where the risk is in this scenario is that little box, as innocuous as it may appear, gives another connection between the IT department's Azure suite and the end user device. So if you were to lump these two pieces together, which would be a reasonable assumption if you are of something that might be done if you were not in the know, you could be, again, casting out the key to the kingdom, the roadmap of your network into a bin of miscellaneous keyboards, mice, and peripherals. But this isn't just any old peripheral. If you were to think about the nefarious actor scenario here, it's twofold. It could be, I'm a nefarious actor with a laptop, I plug in, and then I now have communication with any of the files, payloads that you've got on the IT department's Azure suite, or vice versa. If I want to redirect where this docking station goes and calls out for updates to an end user device, I say, well, I don't want you to go to your company's Azure suite. I'd like you to come, say, to mine, and I can drop a payload that now gives me access to any of the remote servers that you have, or any of the cloud-based applications that your organization uses. These two devices look shockingly similar for having such a disparate function. So for years, where docking stations were just this dumb thing that we would click into that allowed us to have extra monitors and a big full-size keyboard, that's no longer the case. Smart docking stations present a real risk. So it's important that we discuss them as a different class of asset. Now, I've said this, and this might be eye-opening. It might be surprising. It might be something that takes you back and go, wow, we should really be considering this. You want to know who else is considering it? NIST. NIST is the National Institute of Science and Technology. It is Standards and Technology. It is the premier industry standard bearer of how data is managed and sanitized. They curate a vulnerability database that rates and ranks exposure risks. And for this smart docking station scenario, it's a 7.8 out of 10. If it were like a 7.8 out of 50, it would be a different level of risk. But out of 10, 7.8 is high. It's that red square in the middle. The vulnerability database is accessible if you want to go see what other things and how this stacks up against them. But this isn't just theoretical. This is not philosophical. This is a real world scenario where the folks that outline our compliance standards have said, pay attention. So it would behoove us all to pay attention. So two very disparate scenarios with the center of their Venn diagram being unexpected risk. So now we need to talk about how we wrap our heads around your client's appetite for risk. As I mentioned earlier, my appetite for risk is bottom of the barrel low. I don't like it. For some, their appetite for risk is factored in different ways. The perspective that Guardian takes is pretty simple. Data is more important than device. If it takes destroying a device to ensure that none of that data is put into the hands of someone that would act nefariously with it, that is worth doing. Risk is a better contributor to your decision matrix than price. The price of having a service done will always be outweighed by the cost of the damage done by not having that service provided. The risk, the cost of a data breach is always leaps and bounds, orders of magnitude higher than the cost of having that data sanitized on site. And universally, across the board, on site has inherently less risk than offsite. Always. This is the philosophy that we take in our partnerships, in how we draft our procedures, how we behave on site. These are sort of the guiding principles.
Andrew and team, we recently had two different ITAD organizations run into this specific subject matter. Both of them were working with high-tech tech organizations as end users that would know, should know, didn't know. Those particular, when it was identified at their facilities that there were internal drives, it was obviously heightened. Everybody was like, was at the height of their threshold. As we started to explain and give them understanding of what is going on, the types of devices, everything that we're talking about today, and they started to get their heads wrapped around that it really is that what is their customer's threshold for risk, and then that there are services available to handle all risk levels, including this forensic dive into the devices themselves. How does it affect the services that they offer, where they offer them, and if we're doing them on site, how does it affect the teams on site, the time on site? All of those types of things start to get processed as you start to talk to the customers, and it is much, much better for us to have pre-conversations to be dealing with it in a heightened situation, educating the customers so they can go educate their customers and not have the heightened situations, and having, presenting their customers with the service so that they can make some decisions by themselves, the individual organizations, to be able to move forward. So those are some other real world scenarios that we just had.
So data and data risk, understanding data bearing devices. If you'd like to see what a big player in the industry thinks about these topics, you can look to Microsoft. Microsoft has an overview on their website about how they handle data destruction, what their philosophy is, and what they're willing to accept and what they're not willing to accept. At the top, you have the guidelines, policy, and security requirements for data destruction. It is how they intend to handle things, and then definitions of what a data bearing device is, a DBD. This is not an exhaustive list, but it is probably tailored for the way that they've configured their hardware, something we will address, and then that they comply with the categories outlined in NIST's 800-88 Rev 1, which is the current industry standard for sanitization. It's got 3 levels: purge, clear, and destroy. They are associated with different levels of risk concern, risk appetite, and each one is outlined and tailored to do different physical and logical procedures based on the type of media. So it is a very clear rubric of approaches for sanitization. So now let's talk about understanding your client's compliance requirements, because our work is compliant with NIST. We are compliant with NIST because it is the current standard. DoD has gone the way of the DoDO. The Department of Defense hasn't used the standard that they lent their name to in 15 years. It's not reliable. If there are customers of yours that are asking for DoD, it would behoove everybody to have the conversation about updating the requested standard to what is ubiquitously used across the industry. And the reason that is important is that solid state technology was not deep in the market when NISP with a P wrote the DoD standard. Therefore, that technology that methodology isn't applicable to the technology upon which it would be used. An example akin to this would be like taking your vehicle into the shop from, say, the last 20 years and asking them to tune your carbs. That mechanic should look at you and say, your vehicle doesn't have a carburetor. We can do a fuel injection service, but if I were to take the tools used for tuning carbs into your fuel injected car, it wouldn't do any good. I wouldn't be able to give you the service that you are asking for. So that is, as a slight aside, I think at the end of this conversation, if you take a handful of things away, that should be one of them. DoD is not an appropriate standard anymore. NIST is the standard that we should all be complying with, and that it's 3 levels of processing: clear, purge, and destroy, are tailored not only by the type of media, but your level of appetite for risk. If you have zero, if you are a baseline, nothing gets out ever, I don't want there to be any potential, then you destroy everything. But if your institution, if your organization, your end user's organization is interested in repurposing or remarketing, then they would not want to destroy those pieces. They'd want to be in one of the purge or clear categories instead. So that's a conversation that all of us need to be having, is that the standard that we rely on needs to be appropriate to the technology upon which it should be applied. But more than just being compliant with the standard 800-88 Rev 1, your customers might have industry specific compliance requirements that are worth noting and being concerned with. If you're in medical, you've got a certain set of compliances there. If you're in banking and finance, there's a different set of compliance requirements. If you are a government agency, you've got a different set of compliances. If you're tech, cloud, you've got a fourth set of compliances. So understanding your customers' needs, what industry they're in, and what industry specific compliance requirements that they have to uphold is important in translating in order to be the correct architect of the solution for their needs. Well, having said that, let's boil it down. Your client's tolerance for risk and their regulatory compliance requirements, in sum, are the amount of effort that they should be requiring for discovering data-bearing devices, DBDs. That's the umbrella under which all of that information I just gave you is summed up. So let's talk about DBDs. We've given you a story about how we found some. Let's talk about the kind of things that are hiding and where they hide. Well, the answer is they are everywhere. It isn't. Think about this. Think about your cell phone, the phone that you carry with you every day. 40 years ago, if you had a cell phone, you were up there, and it came with its very own bag. Well, now, significantly more powerful, more useful, more embedded in the way that we function, and ridiculously small in comparison. So what we've done is we've taken technology and capability, we've scaled it down and simultaneously made it significantly more powerful. Data storage is the same way. The first 5 megabytes required a forklift. Now, if you were to say want to expand some storage on a laptop or a cell phone, and someone said, well, you can get a 5 megabyte card, we'd all go, right, you're not serious. It would be tiny. Data-bearing devices are the same way when it comes to end user devices or enterprise devices. The space that chassis are taking up now is shrinking in such a way that they can get more out of the real estate of the data center, of the server rack. To accommodate that, the data-bearing device has to shrink as well. It's getting smaller. A 3.5-inch hard drive was a really small form factor in comparison to the 5.25. Well, 3.5 went down to 2.5, which went down to 1.8. From 1.8, it went to MSATA, SATA DOM, M.2, NVMe, and then finally, in a dramatic switch, it went to embedded into the PCB, the printed circuit board. So again, this is a more expanded list, similar to what we saw on the Microsoft slide, but again, not all encompassing. Where data can be written or read from is everywhere. Well, so take a minute to peruse the types of hardware in which you can find these types of data-bearing devices and what they look like. Some can look innocuous, like RAM or a PCI card, where if you look under the hood, you can find in some examples here 4, 6, or 8 NVMe M.2 drives, a whole cache of readable, writable pools of data. Non-volatile dual inline memory modules, NVDIMMs, those are also pretty innocuous looking, but in reality can store confidential, proprietary, industry-specific information. And then the more obvious, the USB drives or the hard drives that look like hard drives, things like printers have drives. It is ubiquitous. If water could get to that area, it's an area worth looking into to ensure that there isn't a hidden data-bearing device.
And it should be noted that the lists that you have there on that slide and the list here are very common devices that we all are very familiar with that have been in the industry or around the industry for a while. invent of the Internet of Things that we're all familiar with in, from a retail perspective in our homes, our stoves or refrigerators or washers and dryers, understand that 90% of Internet of Things is industrial. So our customers, although we're very focused on laptops, desktops, servers, storage, they are encountering a vast array of devices that they just aren't understanding and don't know. If it passes data through it, it's very possible it's storing it. I drive into Dunkin' Donuts and it hits my phone and it tells me, Brendan, you're here and here's the amount of points that you gained today. And is that storing data? That's industrial. But just so your customers and the IT asset managers that are at these organizations, their end users, really need to do a significantly better job of backing up and saying, we don't know where data is lying, and then they'll start to find it.
Oh yeah.
Thanks, Andrew.
If you look, you'll find it. And if you want to think at say 5,000 feet, even if it isn't storing data, it could be pointing at where data is stored. And finding a treasure map that's really well detailed is just a step or two away, 50 paces from finding the treasure itself. So having some safeguards in that regard is also a very important step. Where do you find them? What do they look like? What do those devices look like? Well, they look like every single device that we could run into. That it's blade chassis, servers, server blades, storage arrays, the smart docks that we talked about earlier, the obvious ones like phones, tablets, laptops, PCs. Some of the maybe less obvious ones are your copiers and printers, your firewalls, switches that have onboard configs, or motherboards that have integrated hard drives. Where are they? They're everywhere. And why would they be everywhere? Well, condensing the footprint is one. Additions in the field on site. Someone says, I really like this to have more storage, and they take what the manufacturer sent and put in a bigger one. That would be undocumented by the manufacturer and added in the field. Or if it were serviced by a third party, if you went to like a break fix place to handle a broken phone or tablet, that would be not what was sent from the manufacturer, but potential for additional data bearing devices in the asset. Now we've talked. Now I want to show. This is not internet pulled devices. These are internet images. These are images of things that we have found. These are real world scenarios. That upper left is a wonderful example of how well hidden something can be. That's a Nutanix box. It's a 4-node chassis with shared drives in the front, but each chassis, in this case, in this model, has 2 dual NVMe drives that are on a PCB and vertical, tucked up against the side. So if you were to look at that device and you didn't see a 2.5 inch, but you just saw a bunch of printed circuit board, it would be easy to overlook if you didn't know that this didn't have just one, but had 2 large capacity NVMe drives tucked into the side and then spread out all across all 4 nodes in that single device, in that single chassis. The risk becomes, well, it's linear. The capacity is linear, but the risk is exponential. The Juniper, that's a networking device. And behind that tray that pulled out with thumb screws, not 1, but 2 data-bearing devices, a 2.5 inch drive and a compact flash card. The Dell PowerEdge M640, that's a blade. What you see here, those are micro SD cards, and they are for the iDRAC that we talked about earlier. That's 16 gigs times 2 times every single Dell that has iDRAC capabilities, which, by the way, all of them. I think iDRAC was released in 2001. Again, the capacity is linear, risk is exponential. And actually, let me go back and point out one other detail. If you look in that upper right picture, that's That's the device. And then that yellow circle has a little silver piece with a blue tab and a printed circuit board attached. In order to find these two SD cards, you have to remove that riser to know that they're there. They're not painfully obvious or plainly visible. They're tucked away. Moving forward, the storage array NetApp has a extraordinarily well hidden M2 or MSATA smart card there. 30 gigs. Doesn't seem like a lot, considering that we talked about 18 terabytes earlier. But I'd like to remind you that 18 terabytes was built up of these small building blocks of 16 gigs, 32 gigs, 512. The capacity isn't the driving factor of whether it's worth finding. It's the risk. So that controller module in the NetApp there, you pull it out, and then under a riser card, which you have to remove, you can see that there is that 30 gig smart FISON card. But it's hidden. Even if you were to pull that module out and do just a single visual pass, you would miss it. You have to know that these things are there or have the curiosity to ensure that they are not. This printer example, we've talked about printers having drives in the past. That isn't a new thing, but what we have seen with the expansion of capacities for USB devices is an internal USB port with a very small USB device that's there to hold a config image or a backup image or data for a badging system even. And then this IBM device, that's another module that's pulled out of a networking chassis that you pull the module out under a card that doesn't look like you should really go poking underneath it is a compact flash card. And that the config files for your network will allow a nefarious actor to get an idea of what type of hardware you use, what protocols are being utilized. When was the last time you updated the firmware on these things? Because if you haven't updated the firmware in 3 or 4 years, I've got 3 or 4 years of nefarious knowledge on top of that device that I can utilize to take advantage. So, what is the forensic data bearing device search and removal? Excuse me. It is the service that Brendan mentioned earlier that we offer. It's our drive to provide you 100% data security, that we have the knowledge and the ability to go into these devices and go find them, get into the assets to find the data bearing devices. We have the universal understanding that, like I said, anywhere, if water could get to it, data could be there. So, that we are equipped to go find them, to extract them, and to mitigate that risk across all devices. Like we've discussed earlier, there's not a country road we haven't driven down. There's not a data center we're not familiar with. There's not a device that we can't ensure is clean. And some best practices to live up to that 100% data security. Risk is real. It is nefarious. It slithers in. And it's more important to address the cost of that risk against the price of overlooking it. We take a sort of know nothing, assume nothing approach to where data bearing devices could be put in. We won't assume that there isn't one in there under that card or behind that film. We will go in and know for sure that there is or there is not, but we won't assume. Safety is really important in this line of inspection, in that some of these edges, these stamped metal edges, can be sharp. Really want to talk about lithium-ion batteries. They are ubiquitous. They're used in all sorts of devices, and they don't react well to air, water, or punctures. The risk is real there. So knowing how to handle devices, the innards of a device safely, is really important. We also are meticulous with documenting, and it's important that that everything, all the steps are documented such that we can leverage that the knowledge gained by working with our partners to say, look, here's a real. I'm looking at the data that you sent over. Here's a real possibility that this set of devices would benefit from having a second look at, having the innards inspected, and that there shouldn't be a disparity in the amount of scrutiny that's applied based on the disposition of the asset, whether it's a leased asset that has to go back, or it's a user-owned asset, or it's been sitting in IT's closet for 10 years. The same level of scrutiny should be applied to all of those because risk does not care. Some additional resources to help facilitate the conversations, make sure that we're all speaking with accurate, up-to-date information. I'll point you in a couple directions.
So being a Guardian partner and being in part of our partner model for any of our ITADs, VARs, any of our clients, we bring more than just being able to quote and perform a service or a project on site. We bring education, subject matter experts, keeping our customers and clients and their clients educated onto what's going on in the market. How do you take advantage of that? If you're one of our clients or partners, reach out to your account manager. We're more than willing to jump on what we call Guardian Lunch and Learns to train your purchasing managers and or your sales organizations. If sometimes we're all quite busy, you don't have the time to schedule those, or it's just not convenient. We are on a regular basis putting out emails and blogs, educational libraries on our website. Sign up for the emails. Continually look at our website for educational resources. We're all here to do right by our customers, by our clients, and educating them. This is a service model. This gives the ability to bring this education to your customers, and it brings value, showing it that it brings value to them. So we can help analyze risk, like we're talking about today, and help them develop your customers' compliance solutions. We're always trying to develop policies and processes that give us 100% data security, as Andrew, wants to apply to everything we do. And we appreciate the opportunity to present this. I can't say enough about Andrew Hurteau. He is a subject matter expert of experts in so many different things that we do, and he did a fantastic job of presenting the subject matter to you today. Andrew, do you have anything else?
Oh, thank you very much. Appreciate the kind words. No, I would be happy to field any questions that may have come up from the presentation. If there's anything that comes to mind, please feel free to ask away.
Yeah, Andrew, as an ITAD, what would you say is the best way to encourage a client to even determine if they're overlooking data-bearing devices that are being turned over? Like how, like, would you educate them and let them know? Like the one slide here was the docking stations and stuff, and make sure that they are not overlooking things that would contain data, and just cast aside into a bin somewhere.
I think that we can confidently say, Keith, in this specific subject matter, to the customer, and they may be step back a little bit, but it's not if they're missing data, they are, and we want to help them know where that's happening or how it's happening, and we want to be able to bring that education and that information to their customers. And this specific one, I think it's pretty close to 100% chance that they're not doing the deep dives that we've gone into, and we'd like to relay that information to them. and how you present that to the customer. I think we've all developed fantastic relationships with the ITADs and the VARs and the partners that we have. So I think they'll want to hear us out.
In your experience, are there particular types of devices or hardware that are most commonly found to be hiding these data-bearing storage that isn't so obvious, and ones that have been found by a Guardian team after the equipment was considered clear?
People are amazed. People that have been in the industry for a very long time and that feel like they, in those common ones, Craig, that you're asking about, is their common devices. Your desktops, laptops, server, storage. There's 4 that you would say we know what we're doing. They've been around forever. The answer is you will start opening up today's technology and the way they've built them. You would be, and your customers, and we're amazed as we're starting to do these deep dives on where the data is, and that it's not in just one place. It's in multiple places, multiple different types of storage in the devices themselves, up to and including being embedded on the motherboards. So I think the answer really needs to be is it's not one that's common these days, and you really have to back up and say we don't know, and go into each device that way, and then try to keep a database of things that we've seen on a regular basis, like we've started to do, to be able to make it more common. But taking your eye off the ball, the way things are progressing out in manufacturing, they're just going to keep coming out with more devices because data keeps going through the roof. You just can't sit back and say you know what you're doing. You have to check everything.
Hey, Brendan and Andrew, do you guys think this is a fair assessment of what you guys are saying? It's like before, it used to be like the data bearing stuff was, like you said, desktops, laptops, very easy identifiable. And most of the stuff, we went in there confident that they were not data bearing. Now it sounds like it's flipped, where almost everything is data bearing, and really it's only 1 or 2 things. Like at this point, the only thing that I can confidently say isn't data bearing is an LCD. And even that'll change if you confuse it for an all-in-one.
Right.
The one I have at home is a hub, much like the docking stations. It's a docking station built into a screen, and that's why I kind of chuckled a little bit, because that's data bearing. It's not the most common one out there, but they're out there.
I think you're right. I think the percentage of data bearing assets in comparison, or currently in comparison to what we would have expected 5 years ago, especially 10, 12 years ago, has pivoted in a very significant way. That I would make the claim that more assets have data bearing devices than don't. I'd like to give you a great example about assumption. The one device that really comes to mind about assumption is the series of ThinkCenter M270Q. I'm pretty sure that's right. If you take the little thumb screw and slide the top off, you'll see a cradle for a 2.5-inch drive and an unplugged, or without a drive in it, and then an unplugged SATA combo power and data cable. Then you plug it in, turn it on, and it boots to Windows. So if you turn that device over, away from the area where all the innards are, there's a panel. It's about the size of a deck of playing cards. If you remove that panel, you'll see the RAM and an M2 drive. That if you don't know that it's there, if you make the assumption that, well, I looked and I see where the drive is supposed to be and there isn't a drive in there, if you make the assumption that that means there isn't a drive, you've let go of, well, in my case, a 1 terabyte drive, because I've got a 1 terabyte drive in my 270Q. Well, assumption is dangerous. Assume nothing. Be positive. Go look. You'll see. Any other questions? No. All right, Sarah.
So that brings us to the end today of our webinar about understanding forensic data bearing device search and removal. Thank you, Andrew and Brendan. And to recap, we talked about identifying risk, understanding what a data bearing device is, where they can hide and how to find it, and how even a single data bearing device can add a significant risk to any company's comprehensive data sanitization program. And of course, if anybody is watching the webinar, we're going to have it recorded. If you have any further questions, refer to the slide for the resources, and please don't hesitate to reach out to us at info@guardiandatadestruction.com or look at our website. Thank you very much, everyone, for attending.